Hello, welcome to the Incubator Podcast. This is your co-host, Abir Sren.
And I'm Darren Boyd. And today we are joined by Zach Quiring. He is the Director of Product at Edge Delta. Edge Delta is, we featured Edge Delta on Incubator. We did a research brief, and Edge Delta is in that research brief. So I'd encourage anybody to go to our site. You can download that for free. We're really excited to have Zach on and Edge Delta. I think Edge Delta is doing something very novel. So they're a stream processing platform. This is in that observability space that Sabir and I are very passionate about. But they take a very novel approach in that they do a lot of the analytics at the edge. There's huge advantages to that. And I think they're the only ones that I know of that are doing this type of approach. So we're excited to have Zach on the podcast. Zach, I'll turn it over to you if you wouldn't mind just introducing yourself, maybe a bit of your background, and then tee up Edge Delta. I probably didn't do it a complete service, but if you could tee it up and maybe the problem that you saw as you came to market, I think that'd be a wonderful place to start.
Yeah, that sounds good. And appreciate the introduction and excited to be here and chat about Edge Delta today. A little bit of background about myself. So originally started as a software engineer early on in my career for a few years there. And at the last company that I was at, we started to dabble in various observability and monitoring tools. And kind of at the time, one of the focuses was with log data. And as it was time to kind of move on from that organization, I was looking at different companies and kind of interested in a few. One of them that stood out at the time was Sumo Logic. If you're not familiar with Sumo Logic, they're kind of a core player in the observability space. I think the original focus was around log data primarily, and kind of being one of the first true software as a service cloud-based platforms for centralized log management solution. And I had a kind of a good family friend of mine at the time, Ozan Unlu, who's actually the CEO and co-founder of Edge Delta. At the time, he was kind of on the sales engineering team at Sumo Logic. And so I actually wasn't originally planning on going that direction, but I reached out to him. I saw there were a couple roles open on the engineering team. And after a long discussion with him, it kind of seemed like maybe sales engineering solutions architecture might actually be a better fit for kind of my skill set and in what I was interested in. So he did a pretty good job of convincing me that was the right direction to go. And so at the time, I don't think I'd ever heard of that role before, but decided to kind of take the leap of faith and join Sumo as a sales engineer. And partially, it's a good technology to come into with more of a kind of a technical background. You're working with big data problems. There's a querying, almost a programming language interface involved in there. And so kind of the transition made a lot of sense. So I spent roughly 5 years at Sumo in that capacity, working with customers of all shapes and sizes. Early on, it was a lot of focus around kind of the challenges around log data and analytics and observability there. But as kind of Sumo matured, the market matured, started to really focus on time series metrics and distributed tracing and kind of seeing those different things come together. And so it wasn't until about probably 4 years into Sumo is around when Ozan left to go found Edge Delta. And he was kind of telling me about these concepts and some of the challenges that he kept hearing with the customers he was working with, and some of the pain points and some of the things they were mentioning at the time. A big focus was around the kind of scalability and cost issues and challenges that companies were running into around data volumes growing exponentially. And so at the time, we'd hear of customers maybe generating 1 to 5 to 10 terabytes per day, and that was a lot, but they would be talking about growing to 20 terabytes or 50 terabytes or 100 terabytes. And at some point, they'd hit this inflection point where it basically either it becomes cost prohibitive to start to send all their observability to a tool, or technically complicated. With a platform like Sumo Logic, it's designed to auto scale, and that's less about less of their concern. But a lot of times, if they're exploring like open source technologies, open source solutions, they're having to think about how are we going to scale the indexing nodes, the ingestion nodes, the search heads, the storage, the pipeline that gets the data in. So there's all these complexities that start to come up as different things grow. And he was running into that consistently with a lot of the bigger customers he was working with. Companies might have to consider moving off that platform. Companies we were talking to that weren't Sumo Logic customers, but they were kind of exploring their different options. The barrier to entry at kind of their scale was just starting to get difficult, and that wasn't just a Sumo Logic problem. As all the different observability vendors they were talking to starting to kind of hit these limitations, and so that's really kind of what spawned the idea of having this understanding of how do people use these data sets, what are the most optimal ways to process, to get the visibility, to really extract the value out of that data without necessarily first having to send all of it to a central tool and then start to glean insights, derive analytics, and do these different things. So that's kind of what spawned the early kind of concepts and ideas of Edge Delta at the beginning. And then I stuck around for another year before kind of joining as kind of the company started to mature, but was still pretty early on in kind of the journey of Edge Delta. So I think the concept, kind of the core original concepts of this concept, like we refer to the edge as close to where the raw data is being generated as possible. And what are the things that we can do at that layer to either augment, to enhance, to kind of combat some of these limitations, to really so that people can not only maintain the same experience as their data volumes continue to grow, but also leverage some of the kind of benefits or value that this concept of stream processing unlocks that otherwise would not be possible if you were just starting by shoving all your data into a central solution, then trying to run batch processing on massive amounts of data. The things that you can do kind of on that side of the equation are much, much more limited because the compute that it takes, the memory, like if you want to run advanced algorithms, there's so much that has to be done. Whereas if you can start to glean insights at the point of where the data is created and push those insights to a central location and run algorithms on a much, much lighter weight version of that data, it unlocks tons of different things that you can do. So that's, at a really high level, kind of some of the basics of what Edge Delta is designed to do. There's a lot of different use cases we solve for. We kind of talked originally about this concept of like data optimization or handling large data volumes, but as the kind of the product and the company's matured, a lot of focus is around this concept of like automated observability using that kind of, stream processing functionality that kind of allows you to do a lot of different things. So yeah, it's been cool to kind of see that journey and be a part of that. And, it's definitely, like you mentioned, something that's a little bit unique in the space. I think, a lot of people gravitate towards there's a ton of players in the observability space. There's, the Datadog, the Splunk, the Sumo Logic, the Elastics, the New Relics of the world that, at a core level, they're all kind of doing the same thing in one way or another. It's, hey, let's put our logs and metrics and traces in one tool. And we have dashboards, we have queries, we have searches we can run. Obviously, there's differences between all these technologies, but the innovation being done at that layer between where the data is being created and these downstream systems, which we love all those systems where, we have native integrations for everything. And, we're kind of designed to help those systems perform better. But kind of the innovation at that kind of first layer is something that's a little bit unique about Edge Delta, where we don't necessarily have to compete with these massive players in the space, but can kind of provide value, with these data sets along the way. I know that's a really long answer and hopefully not too much overhead, but hopefully that's helpful.
No, lots to unpack there, but a great starting point because this is one of our favorite subjects. I don't know if you were going to go somewhere otherwise.
Sure. I was going to say the same thing, Zach. There's a lot that you covered over there, so maybe we can break it down and simplify it for our audience and listeners here. So if we maybe on just a last thought of you're complementary effectively to the Datadogs, the Dynatraces, et cetera, out there, because and you're providing analytics at the same time at the edge. So where would you kind of build up that differentiation of value at the edge from an insights perspectives? What types of data are you ingesting? Logs for sure. And then how are you able to develop that analytics picture at the edge to deliver effectively instantaneous value?
Yeah, definitely. So I think kind of going into that, the second piece of the question first, like what are the things that we do at the edge and how is that different than, maybe just centralizing all the data first and kind of what that unpacks. I think one example that kind of helps simplify that is if you think about like a dashboard in a one of these different platforms. By that's in taking, let's say, log data as an example. So a lot of times we'll work with these like really high volume data sources. Like it could be things like Apache access logs or load balancer logs or CDN traffic or things like that, which generate massive amounts of data. And traditionally, if you wanted to have observability in that data or derive insights or build alerts or something like that, you first need to send all that data to a downstream tool, and then you have queries that actually do kind of the processing of that data. So you might say, hey, for my this given application, I want to monitor the rate of like 400 status codes, 500 status codes, millisecond response times, the error rate, the exceptions, all these things. And traditionally, you would need to first send all that data, and then you have the queries that actually, analyze that, look for the interesting things, derive the analytics that you need. But then the final result of that process, if it's, let's say, something that's on a dashboard or something that's alerting, it's just a set of like very, very lightweight statistics that have been exposed from that data. But its starting point is the kind of a very, very heavy footprint of raw data that it needs to do aggregations on and time slices and all this stuff to eventually get you what you're looking for. So you can kind of think of, one of the concepts of what we do is saying, rather than first, if we know what we want to grab from this data are these kind of core KPIs and things that we want to have visibility into, why don't we have something like Edge Delta that can look at that same feed of data at the point of where it's being created, and rather than always forwarding every single raw event downstream, it can inspect every single log, pull out these different KPIs, send those in a much, much more lightweight or optimized footprint so that, if we have a dashboard or an alert in a downstream tool, it doesn't necessarily need to query all of the raw data. We don't even necessarily need to send all that data. We can still get the insights that we care about on one 100th, 1,000x the ingest, the data volume. And also that means we don't have to kind of maintain this like extremely heavy pipeline of the agents that collect the data. There might be an aggregation layer, there might be something like a Kafka, this whole kind of end-to-end pipeline along the way. And that all starts with let's derive analytics from this data much closer to where it's being created. That also allows for benefits around from an alerting perspective. There's a lot of hops that data typically needs to go through from, it gets picked up by agents, it goes to these different pipeline components, it then, gets indexed, your alerts run on, maybe it's once a minute, once every 5 minutes. And a lot of times that can introduce, 10, in organizations we talk to, a lot of times it's like 10, 20, 30 minutes of latency before uncovering something. But the ability to say, hey, if something's happening in my data, that's also kind of another function we can expose, is saying, I want to get an alert as soon as we're seeing these deviations and not be forced to go through all these hops. So there's kind of a few different things that come in that domain there.
Yeah, and there's a lot in that. Like there is so much value packed in that approach. Because one, like we've seen folks, we've seen pipeline products that can remove some of the superfluous and maybe even cull some of the noisiness of data, so they can do various activities in that domain. But by putting the analytics there, to your point, not only can you get to something actionable faster, but we're also removing some of the burden, because all those platforms, or most of those platforms you referenced, they charge when that data hits, and they have to process it. So there's an immense value with that approach unto itself. But it also begs the question, What do I lose as part of this? So what from a performance perspective? Because I am amazed at some of the benchmarks that you've shared, extremely performant at the edge as well. What does the overhead look like of decentralizing some of that activity and those patterns, and processing closer to the execution of code? What kind of burden can we expect in that architecture?
Yeah, I mean that's a good question, and it's definitely a common question that comes up. I think one of the benefits that we've had is that's probably been the biggest focus from, one of the biggest focuses from day one from an engineering standpoint of, if we're going to move some of this processing and analytics closer to where the data is being created, and potentially in certain cases suggest to, add another agent or replace an existing agent like a, Fluentd or Vector or whatever those might be, it has to be extremely performant. And so, the agent itself is written in Go with, these kind of, you mentioned some of the benchmarks, like that's been a very intense focus. Is anytime we introduce new functionality, doing core load testing and benchmarking, making sure that the performance impact will be negligible as part of that, continuously improving those components. So the nice part is, even though in certain cases there's more things that we're doing locally than just collecting the raw data, compressing it and sending it somewhere else, in most cases, it's still a lighter weight footprint than the potentially incumbent agent that exists there. We kind of mentioned a few agents, that might exist on these nodes. And so that's the biggest focus. One of the bigger focuses there is, not only are we getting potentially like additional benefits by taking this approach, but we can get rid of other services that we might have running there and still bring down some of the kind of the resource utilization or whatever those things, we track, like CPU, memory, IO, all those different things. So, typically what we see is the impact is negligible compared to any other agent that might be ran on these nodes. I think that being said, it is probably worth noting that there's multiple like architectures that we support. So there's things that we absolutely would recommend, hey, let's do this as close to where the data is being created as possible, and this is the value of doing that. There's other cases where that just might not, it just might not make sense from technical reasons or whatever that is. And so we also have options to kind of be deployed as more of a central model where data is flowing through kind of the Edge Delta pipeline. We're doing these same functions as the data is flowing through and then routing to different destinations. But there's, absolutely discussions around, typically it gets a little more into the weeds when we're kind of uncovering what makes the most sense. But that's also, a flexible option that we expose as well. But going back to your question, it's definitely something the team's focused on and, continues to make improvements and kind of drive that forward.
Thanks, Zach. Just building a little bit further on the architecture aspect of things. So we're finding many of our customers, clients are starting to look at open telemetry. And how does Edge Delta fit into the open telemetry view of the world from an architecture standpoint? And yeah, just your feedback there.
Yeah, definitely. So open telemetry is, something that we're super excited about. There's quite a lot that we're kind of doing in that domain at the moment. For anyone that's like, something interesting there, I remember sitting on some of the early kind of calls with the kind of the open forum discussions around, at the time it was the logging agent specifically for open telemetry. This was maybe a year and a half ago, maybe 2 years ago. And it was cool seeing the, on the calls we would have, there was one of the co-founders and some of the chief architects from Sumo Logic, from Datadog, from Splunk, from Lightstep, from New Relic, from Amazon. And, that's typically not a group of people that you would see in the same room. And then, beyond that, collaborating and trying to kind of come up with something that's really going to benefit everyone, benefit the industry and the space and things like that. So, there's kind of a few things that we look at from an open telemetry perspective that are kind of exciting in the domain we live in. One of them is the kind of a normalized like schema or format of data types. So whether it's, the tracing data, which is, pretty well established at this point, kind of the normalized format for log data and field names and things like that. If you've, if you spent time in a log management solution, like writing regexes and trying to parse fields and get everything to line up, it can be a little bit of a mess. So the more that can be done in that domain to kind of get everyone on the same page so that a downstream system, whatever tool you're using, can focus on the kind of the benefits that we can get out of this data and less about like trying to construct it and manage different things there. So I think in our domain, kind of the two big things, there's a lot we're doing around like native integrations, our agent being able to consume, or our pipeline be able to consume like OTLP data for all the different logs, metrics, trace data, both consuming as well as exporting downstream. There's a lot of automation that we're building around like being able to process that data because there's these normalized schemas. There's things that we can look for and automate and kind of derive insights without a user having to, specify anything. So that's something pretty exciting that's being done there as well. And then also some things that we're, kind of looking into in the moment around potentially like a distribution of kind of the Edge Delta agent for open telemetry, similar to, a lot of other players in the space have kind of expanded around the kind of the open telemetry collector and agent and things like that. So there's a lot that's going on in that domain right now. I think as the kind of the adoption grows and the maturity of kind of the open telemetry space, I think you'll kind of see Edge Delta aligned with that direction. But it's something, we're super excited about, and, seeing that kind of come to fruition over time. I think it kind of reminds me of, I remember, maybe 4 or 5 years ago at Sumo Logic, we started to hear like, first it was Docker and then like Kubernetes come up. And people would, ask like, hey, what's your support for Kubernetes? What are you doing? Like, we're thinking about going that direction. And we'd start to drill in because at the time, we didn't necessarily have the most like amazing solution or use case or way to handle like Kubernetes data or Kubernetes clusters or whatever that was. And I don't think many of the, technologies did at that time. And so we'd kind of dig in a little bit further, and it was kind of like the cool thing to talk about. And, kind of question, hey, what are you doing around, Kubernetes? But when we dig in, it kind of turned out that maybe it was something that was being like tested in a lab, but probably years off in, that company from actually being like widely adopted and being used. And it kind of feels like certain parts of open telemetry are kind of at that stage, like definitely a lot further. But, we're starting to see like, we're having conversations around open telemetry the last, 2-3 years. And I think right now is where it's really hitting that inflection point and kind of starting to take off. And, I think it'll be everyone's benefit if that becomes the standard and becomes the norm over time for all the different data types. I think that adds a lot of benefit and kind of value to the market. But yeah, so I think, it's kind of an exciting space, and seeing that adoption grow, I think there's a lot we can do there.
Yeah. Just you hit on something that I'd like to just take the opportunity to expand on, Zach. So you mentioned Kubernetes. So what exactly is Edge Delta's focus around Kubernetes as a platform for observability?
Yeah. I mean, there's kind of a lot that we're doing there as well. So like our back end, everything from an engineering standpoint was like natively designed from day one, running Kubernetes. We're blessed to have a lot of very advanced like Kubernetes experts on our engineering team. So there's a lot of cool stuff that we can do there. But I think like from a product standpoint, what's like, we've seen that trend significantly, pretty much since the company was founded, in terms of like the adoption of Kubernetes. Early on, it was maybe like 30-40% of the organizations we were talking to. I think, as that continues to grow, I think it's, almost 80-90% of the organizations we're talking to are using Kubernetes in some form or another. And, a lot of them are like, all of their infrastructure is being ran on Kubernetes. So one, we've kind of like, with some of that expertise in house, I think it's allowed us to, one, make the kind of the deployment of what Edge Delta does, integrating with Kubernetes, using a lot of the native functionality there to make that as like seamless and easy as possible. To be able to one, just kind of use Edge Delta to monitor a Kubernetes environment, but also, we kind of talked about this concept earlier around like automated observability. So saying, hey, if I just deploy the Edge Delta agents in my Kubernetes cluster, let's say like a daemon set, for example, that allows us to do auto discovery of all of the native Kubernetes components that are running, all the pods, containers, namespaces, everything else, collect all the metadata. And then, a traditional agent would do that, collect the raw data, add those tags and send it somewhere else. But the way that we're able to do some of this processing and analytics locally allows us to also kind of really enhance that automated observability kind of umbrella of saying, like, we're not just going to collect your Kubernetes data. We'll be able to analyze it at the point of where it's being created, and then do a ton in the form of helping pinpoint potential issues or things that we're seeing or deviations from the norm, down to, hey, this particular namespace, the way we look at it is this concept of like, anomaly detection and baselining. So we can, within seconds of deploying the Edge Delta agent, it's analyzing this data, it's creating baselines of what normal patterns look like for these observability data sets, and creating those independently for all the components that we see, the pods, the namespaces, the services, all these things, creating these trends. And then if there's some deviation, like, hey, this particular, we're starting to see something interesting in this namespace, and within that namespace, it's this service or these set of containers, they're doing something totally different than what we normally see. We can pinpoint those things and, kind of do all this. And the nice part is it's all automated, and it wouldn't be possible if our platform was just consuming all the raw data and then trying to do these things. It starts with analyzing the data at the source, creating kind of lighter weight analytics about what we're seeing, and then being able to run much more kind of advanced algorithms on that stuff. So we're super excited about Kubernetes. It unlocks a lot of automation capabilities, deployment kind of functions and things like that. And I think it's also just a big catalyst to kind of this like growth of data that we're seeing as companies, kind of first it was the move to the cloud, and then to containerization and microservices, and Kubernetes is a big part of that, and that just leads to exponential growth in data volumes. And it's something that as companies are adopting Kubernetes, that's typically what we see is they're like, our data volume just doubled overnight, and they were already 3 times higher than we wanted them to be. So it's kind of cool. So so we love Kubernetes, and I think there's a lot that we're doing in that domain as well.
Yeah, and there's a lot going on in that in your description there too, because one, we work with customers that sometimes will want to roll their own, but and sometimes they'll say no, from a time to market perspective it makes sense to do COTS. But in every case, the idea of this passive capability where if I deploy something like Edge Delta, I can immediately get benefit without necessarily going through just a myriad of configuration and tuning and adjusting and so on and so forth. And it's in short order, is actually a really, really huge selling feature, because that seems to be what everybody's busy. Product teams are busy, developers are busy. And so if they can get some insights right away without having to invest a lot of time, they're, lost engineering cycles or degraded engineering cycles on things that are non-core, people tend to guard against. And so getting that passive capability is huge. We love that. But you're also, and by the way, all things CNCF, I think, we're a big fan. We're a big fan of open source. We like your commitment to open standards. And I think that's something else that our customers are really appreciative of, because they want choice, and being tied in, especially at the bytecode level, into various products makes it very difficult for them to experiment later. You're allowing experimentation. You're taking from multiple sources. You're sending to multiple destinations to facilitate some of that as well, which is really endearing to the product. But one question that comes up often, or not a question, an objective for every one of our customers is they want to guarantee right? Because now we're going to come back to how do we actually manage this at scale, especially when it's decentralized. They want to guarantee that only approved sources going to approved destinations with approved data types in formats that are accepted to their IT narratives. That's the only data that's routing, and only approved eyes can see it. How do you manage an Edge Delta deployment that is decentralized via agents at the edge to ensure some of those parameters are maintained, understood, and auditable?
Yeah. Yeah, so there's a few different things that go into that. Like from an architecture perspective, to kind of simplify the basics of what we do. We have a concept of inputs or sources, which are what are the streams of data that we're collecting. That could be as simple as reading from a file, listening to a TCP UDP port. If it's something like a containerized environment, reading from containers and things like that. It can be more, reading from things like, an S3 bucket or a Kafka topic or a Kinesis firehose or whatever that is. So one is kind of getting data flowing through the pipeline. The next piece is what are the things that we want to do with this data as it's flowing through. In a lot of cases, it's as simple as, hey, we're like, obviously there's analytics that Edge Delta is going to derive, but we want to make sure that certain data sets make it to what we call their streaming destination. So that would be the platforms like Splunk and Datadog and Sumo Logic and Elastic, and kind of sending data to those systems. There's also a concept of what we call archive destinations. So typically those would be like a S3 bucket or blob storage or Google Cloud Storage, where that's kind of a whole nother story in terms of the types of ways companies are kind of leveraging things like whether it's Athena or Snowflake or BigQuery and kind of on those data sets. But like at a fundamental level, it's these sources that we're collecting, some logic around routing and where data goes, and making sure that ends up in streaming destinations. So like part of that is managed through like standard role-based access control. So who has access to do certain things, who has access to kind of touch certain sources and kind of decide what data gets sent where. That's managed through different roles and policies we can get in place. The nice part is we can actually be like very granular about who has access to what. So for example, we could say, hey, there's this stream of data maybe coming through from a set of Linux servers. We have a cluster of EC2 instances, and we're monitoring. We have the application logs, but we also have like the system logs that have audit and security types of events that we want to forward off to our SIM and do something there. We can kind of give like very granular controls over, hey, these inputs, only these users can kind of modify those and touch those. And these other users have no visibility, maybe not even invisibility that those are even like being collected or sent downstream. And then part of it's also managed in the streaming in the streaming destination tool. So a lot of times there's already like access policies in place, which users have access to search, like which indexes, and that's usually kind of, another place that logic lives. So making sure that we're mapping what we're sending to the destinations that kind of have some of this logic built. So it's a little bit of, kind of both domains there, but it's, kind of just managed by different policies. And then there's a lot that we expose around, and I think this is pretty important. It's, not necessarily there's a lot that we expose in the form of like visibility and like the health of a pipeline. So, you might have a downstream platform that you're collecting and sending data to today, but knowing what's happening along the way, are the agents collecting what they're supposed to? Are they always successfully sending downstream, the data downstream? Is every event making it there? There's a lot that we do and kind of are continuing to enhance in like that spectrum, because a lot of times we'll notice, a customer has an existing solution and they'll, run a particular query or look for something that data is just missing. And it's because, whatever was collecting that data just for whatever reason hasn't been for, maybe a week or two. And they have no visibility into the fact that, what they think, because they might have SLAs and compliance, requirements to collect everything and send it somewhere. But they they don't necessarily have a way to guarantee that that's happening. So kind of living as, a big part of our product being that pipeline that moves the data around, I think getting that visibility is pretty helpful. So
And can you
yeah, so
handle,
stuff like that.
can you handle some survivability scenarios such as, destination, like you said, maybe the destination is unavailable, or maybe it can't consume at the rate that you can send, and therefore you need to invoke some back pressure mechanisms. Do you have some scenarios to, I guess, either survive periods where there's some degraded state in the environment and then recover from? Is that what I should take from that last segment you just shared?
Yeah, definitely. I think, part of it is simple like retry logic at the pipeline level. Hey, we're sending to this streaming destination. Did we get the expected response? There's things that we can look for in those tools to kind of ensure that happened. And then also, if AWS is down and, they're running a platform that's built on AWS and, there's no way for our pipeline to send data to that tool, then there's different options around like local caching mechanisms, storing data, storing the compressed data, and then basically like checking until that connection's been reestablished and kind of flushing and making sure that data is made available downstream once that system's ready. There's a lot of different like levels you can go to in terms of kind of making that as bulletproof as possible. So we just kind of provide different options around that piece, and so I think that's definitely that's a little bit table stakes in terms of kind of at least like basic enforcing that, hey, there's retry logic, we're storing data as needed if a downstream system's down. But then a big part of that is also like bubbling that up to either administrator or user of, hey, like, by the way, we can't send data to this tool right now. Maybe that system's down, like go look into whatever that is. So one is just like doing the necessary steps to make sure that's happening, but also providing visibility into, so users know that things are happening as expected, or if it's not, that, kind of have some visibility or some alerting or dashboards to know what's going on there.
Yeah. Zach, I want to take the conversation back to something you mentioned earlier, the whole cost value proposition, right? So historically, data is increasing, companies are paying exorbitant amount of fees and et cetera, from a licensing perspective. Can you elaborate further how Edge Delta actually minimizes the cost aspect of things, in addition to providing the insight and analytics capabilities at the edge?
Yeah, definitely. So I think it comes in kind of a few different forms. One of them that's pretty like something we'll dig into pretty early on. This applies to kind of both, I would say, like primarily log data as well as distributed tracing data, is understanding a little bit about like, take a handful of like high volume data sources that are like, a lot of times a customer might be sending, 20, 30 different, a lot of times it's a lot more than that actually, but like down to a downstream platform, but it's a handful of those that might be like the biggest hitters in terms of how much data they generate. So it's understanding like, how are those data sets used downstream, and what tools in the Edge Delta pipeline can we turn on to make sure you're still getting the visibility that you need into that data set, but not necessarily needing to send all of that data. Like maybe a better place for the raw data would be something like, S3 or somewhere else where you always have access to it when you need it, but the analytics that you need are always sent to, it could be a time series destination, it could be a management tool. So part of it's just kind of like looking at those data sources and kind of using our pipeline to gather what you need so that you don't necessarily always need to see those. And if you can reduce the volume of data that's sent downstream, then that's something that'll, have a massive benefit from like a cost perspective of whatever, tool. It might not necessarily be a license cost. It might be like an infrastructure cost, is a lot of times when customers using open source technology. So that's one of the forms. The other would be, I think that applies to like, distributed tracing data, for example. Like a common theme we run into is a customer I have in mind right now. They generate close to 100 terabytes of raw data per day across their different telemetry data types. Their engineering team is roughly like 700 to 800 across, software engineers, developers, DevOps, SREs, et cetera, that might be an end user of that data. And even with, 800 engineers who are potentially pounding that downstream observability tool with queries, looking at, dashboards, alerts, all those different things, like technically can probably only maybe like query or look at a fraction of a percent of that data in a given day. And so that means on average, like 99% of what's being sent downstream is either never being looked at, um, is like not necessarily having the value derived out of it should. Now there is an aspect of like automation that's typically done. That's typically what like dashboards and alerts are doing, is they're continuously querying that data to give you the analytics that you need, so you don't have to run your own raw searches. And that's where kind of that last concept I was talking about of kind of baking that into our pipeline, so those analytics are always being created. And then it's kind of being like more trying to be a little bit more specific about like, hey, how can we automate making sure that that 1-2% of the data that people need and need available when they need it is there when they need it. And then kind of be like systematic about understanding, what are the best approaches for these other data sets where we can make sure they're always available. We can always derive analytics from them, but don't necessarily need to be, indexed and ingested into a platform where they're not like realizing the value of that data, potentially paying a lot of money to do that. So there's a lot that goes into that. That comes in with like distributed tracing data. It's like kind of the same concept we see there where, one of the companies we're working with right now, it's similar. It's close to like 200 terabytes per day. And that was, they aren't using anything for distributed tracing right now. They want to, they're starting to set up all the instrumentation and do everything. And now that they're kind of getting like a mature deployment ready to go, basically realize like this is going to generate 200 terabytes of data, which is massive. And, like even if someone by hand clicks on every single, all day, all they do are click on transactions and look at the details, like they can maybe only look at, I don't know, between their team, like 100,000, like a million maybe, and there's 10 billion being generated every day. So how can we be like a little bit more efficient about like making sure the right data is there when needed, the analytics that we need are needed, that every single like transaction is inspected, but not necessarily like send it all downstream and do stuff. So I know that's a long answer there. There's a lot of other things that we do along the way, and kind of options we unlock that kind of wouldn't be possible with different architectures. But hopefully that helps a little bit.
No, it certainly does. I guess one last question for me would be, so Zach, if a customer they want to try it out, they want to see what this can do, how much of the infrastructure do they really need in place to start seeing the value right away? How disruptive does this have to be? I know it ties into existing tool sets, so I think the barrier is actually fairly low to get started. But what's a good entry point look like if somebody wants to try your product, your platform, and start to see the value?
Yeah, that's a good question. I think in terms of infrastructure that needs to be set up, luckily, like there's nothing really extra that we need to deploy in an environment, at a basic level to be able to test the functionality, to integrate with existing systems and things like that. Take like something like a Kubernetes cluster as an example. I would say, a lot of times, essentially all we'll do is say, keep the existing pipeline you have in place. Like don't change anything. You don't need to modify, any of the practices you already have. But let's deploy, in Kubernetes, for example, let's deploy the Edge Delta daemon set in parallel to what you have. We can tie that to a downstream system and then, start to evaluate what are the, one of the concepts we look into is concept of like data optimization is a kind of a metric that we have in our platform. And so, whether that's a use case or like automated observability is more the use case, then we'll focus on, hey, let's kind of understand like the findings that were generated and do some of those things there. But I would say from the easiest way to kind of get started is usually just kind of walking through that process, deploying Edge Delta agents. If we're sending data to a downstream streaming destination, getting that piece integrated, and then kind of, exploring the different use cases and essentially understanding, is it if the focus is a data volume use case, then we'll do some kind of comparisons, current state versus, kind of using Edge Delta. And is it, the trade-off of data volumes and kind of, whatever, like do some things there. So yeah, I think it's just really kind of like the setup is really easy, and that's something we focused on, since very early on. And we're only scratching the surface of what can be automated and what can be, make just easier to consume and digest and stuff like that. But yeah, and typically we have our, like, if it's a more complex use case, our solutions engineering team will kind of hold hands through the process and make sure, whatever the goal is kind of clear that Edge Delta can, hopefully solve those use cases.
All right. Thank you so much, Zach, for joining us today. Very informative discussion here. We hope that our listeners here find it insightful. And if they have questions, they're welcome to reach out to Darren and myself, as well as Edge Delta will support the connection points. Again, thank you, Zach, for joining us.
Yeah, thanks, Zach. Appreciate it.
Yeah, thanks for having me on. And yeah, I really enjoyed it.
Take care.
Okay, bye.